So today we are gonna finish up with our review material for quadratic stuff. And we're gonna take a look at some of those graph problems. So your graph problems on the Unit 8 test came in two varieties. There was a section where I gave you the graphs and I gave you some functions and they were essentially matching. So you had functions that you were trying to match to their graphs. Most of us did pretty well on that matching stuff. Where we struggled was on the other type of question that I gave you, which was similar to what we're going to focus on for today. So I gave you a graph and asked you to give me the three different function forms for that graph. So that's what we're going to focus on for today. Okay. So on page 5, number 17, I've got a graph here, and I want to give those three different function forms for this graph. So if you remember last week, we looked at switching between those different function forms. And then we also looked at, if I have a function, what key information does it give me? So we're going to start with vertex form here. If you remember, again, from last week, we identified vertex form. We said it gives us the vertex, and then we could pick out the vertex from our function. What we're going to do today is basically the same thing, but in the opposite direction. So we're going to start by identifying the vertex and then plop it into vertex form. So we're going to start by identifying x-intercepts and then plop it into that intercept or factored form. Okay. So on page 5, number 17, we've got a graph here. We're going to start with vertex form. So I want to identify the vertex of this function. So my vertex here is -2, -1. So I want to drop this into vertex form. So for vertex form, I have x with something squared in parentheses, and then some number here at the end. These parts give me the coordinates of the vertex. So if I know the coordinates of the vertex, I can throw them into vertex form. If the x coordinate of my vertex is -2, that means I had to have x plus 2 in parentheses. If the y coordinate of my vertex is -1, that means I had to have -1 at the end of my function. With me so far? Okay, if we can pick the vertex out of vertex form, we can certainly take a vertex and put it into vertex form. And then the last thing I need to worry about here is my lead coefficient. So what we expect for the shape of our graph is from the vertex to get to our next nice points on either side is that we go up one and out one. So if I look at the next nice points that I have, the ones that are kind of on corners, from my vertex, I go up one and out one. That's what I expect. That matches my parent graph. Since that matches my parent graph and it does what I expect, that means my lead coefficient is 1. And when it's 1, you can write it or not, that's up to you. We know multiplying by 1 doesn't change our problem. What we expect is for the lead coefficient to be 1. If it does anything outside of what we expect, if it goes down, if it goes up 2 and out 1, anything like that, then that means we've got a different number. Questions for me so far? Okay. Now we can use vertex form to get these other two function forms. That's what we did last week. And for this problem here, we said we have vertex form, distribute it to get standard form, and then factor it to get intercept form. Could do that same thing here if we wanted to. What I'm going to show you today is how to get this intercept form, or we also called it factored form, directly from your graph. Since we know it gives us key features, we're going to practice using those key features to write the function. If you wanted to, if you're more comfortable saying distribute this, get standard form, and then factor that to get intercept form, that also works, just like what we did on Friday, okay? And I'm going to show you a different approach. So we know that intercept form gives us the x-intercepts. So if I look at my graph, my x-intercepts are -3 and -1. So that means my intercept or factored form is going to have the same lead coefficient as vertex form because the graph has the same shape. And then I know I should have x in parentheses with something twice, right, for that intercept form or that factored form. Now what I want to fill in will be determined by those x-intercepts. So I have an x-intercept at -3. That means I had to have x plus 3 as one of my factors. If I have an x-intercept at -1, that means I had to have x plus 1 as one of my factors. And there's my factored form, or my intercept form. Our last function form here, standard form, we know shows us the y-intercept. So we can see from our graph that our y-intercept is 3. So I know that this function ends with +3. The bummer about standard form is that since I see the y-intercept, I get that constant term, but I don't get anything else. I don't get the x² term or the x term here, okay? I don't get that from the graph. So what I'm gonna have to do for standard form is distribute one of these guys. I'm gonna choose to distribute intercept form, but if you would rather distribute vertex form, that's fine too. But I'm gonna have to distribute one of the functions I've already written in order to get all of standard form. So x plus 3 times x plus 1. Remember to distribute completely. So I get x² plus 1x plus 3x plus 3 for standard form. Don't forget to combine your like terms. So here's my only x² guy. And then plus 1 plus 3 would be plus 4x. And then plus 3. Questions for me for number 17. Okay, so we're just going to do this a couple more times. We're going to do a couple more practice problems. Same idea. For number 18, again, we're going to start with vertex form. So I want to identify my vertex here. 1, 2, 3, comma 4. So that means for my vertex form, I had x in parentheses with something squared, and then something at the end. Since the x coordinate for my vertex is 3, that means I had to have x minus 3 squared. Since the y coordinate for my vertex is 4, that means I had to have x plus 4, or sorry, plus 4 there at the end. And then the last thing I want to check is the shape of my graph, because that tells me about my lead coefficient. Okay. Remember in that last problem, we said we expect from the vertex to get to our next nice points to go up 1 and out 1. For this graph, to get to our next nice points, so here and here, we're going down 1 and out 1. Since we're going down, that means our lead coefficient needs to be negative. So you need a negative sign in front or a -1 if you'd rather. Since our parabola opens down, we need that negative in front. So there's our vertex form equation for this graph. Now we're going to write factored form. So I'm going to start with y equals, and then I need that negative in front still, same lead coefficient because I'm describing the same graph. But this time, since we're going to give intercept form, I need to know the x-intercept. So I have an x-intercept at 1 and an x-intercept at 5. And again, I know for intercept or factored form, I'm going to have these factors with x here. To get an x-intercept at 1, that means one of my factors had to be x minus 1. To get an x-intercept at 5, one of my factors needed to be x minus 5. And there's my factored form. Now, finally, for standard form, again, we're going to have to distribute one of the functions we already have. Again, I'm going to distribute our intercept. So this would be negative x minus 1 times x minus 5. I'm going to multiply these guys first. So this would be x squared minus 5x minus 1x plus 5. And then we need to distribute through that negative 1, that lead coefficient. So when I multiply that through, I've got negative x squared plus 5x plus 1x minus 5. Just changes all my signs. And then for standard form, I need to combine like terms. So here's my only x squared term. So negative x squared plus 5x plus 1x would be plus 6x. And then there's my only constant term, minus 5 there at the end. And then it's always a good idea to make sure that your constant term from standard form matches your y-intercept on your graph. Okay, so we've got negative 5 here, and our y-intercept is down at negative 5. If these don't match, then go back and double check your work. There might be an error in there. Questions for me on 18? Great, please. Okay. Turn the page. Let's look at number 19. So number 19, same idea. We're going to start by identifying our vertex. Remember, the vertex is always going to be either the minimum, or if my parabola opens down, it'll be the maximum point on my graph. That's why we're starting with vertex form, because it should be a point that you can pick out pretty easily from your graph. Okay, so my vertex here is 1, negative 2. I'm just going to kind of set up what my vertex form should look like. If the x coordinate of my vertex is 1, that means I had to have x minus 1 squared. If the y coordinate of my vertex is negative 2, that means I had minus 2 at the end of my function. And then again, I want to see what my lead coefficient is supposed to be. That's the shape of my graph. That's what that tells me. So we're opening up, so I know it's going to be positive. But if I look at where my next nice points are, the points that land on corners, that would be these guys. From my vertex to get to them, I have to go up 2 and out 1. Since I'm going up 2 instead of just 1, that means my lead coefficient is 2. Questions on our vertex form here? Okay. Now let's look at our factored or intercept form. So we're going to pick out our y-intercepts for this. So I have a y-intercept, or an x-intercept, sorry. I have an x-intercept at 0 and an x-intercept at 2. So my factored form, again, same lead coefficient, would look like 2 times, get my factors set up here. And then I'm going to fill in the blanks based on my x-intercepts. So if I have an x-intercept at 0, that means I had to have x minus 0. Or this could also be x plus 0. And then if I have an x-intercept at 2, that means I had to have a factor that was x minus 2. Now, a minute ago, I said it doesn't matter if you write x plus 0 or x minus 0, because adding 0 or subtracting 0 doesn't change anything, right? So because we've got 0 here, we can actually clean this up a little bit. I could write this, since subtracting or adding 0 isn't going to change my x at all. I could actually clean this up to be 2x times x minus 2. We saw a problem similar to this last week when we were trying to identify this function form. We said, well, that x actually came from something like this, so that means it was factored form or intercept form. So we could also clean this up to look like this. I would take either version if I asked you to give me that intercept form for this function. Both of these are correct, and I would accept either. And then for standard form, again, we're going to have to distribute. I'm going to choose to distribute this guy right here. You could distribute vertex form or that sort of non-cleaned up intercept form. You're going to get the same thing no matter what, as long as you're careful with your distribution and combine your like terms. But this one's going to be a little bit faster and a little bit easier to distribute. So this would be 2x squared minus 4x. There's my standard form function, 2x squared minus 4x. What's the y-intercept that I would get from this function? I don't see a constant term here. Yeah, 0, right? If I don't see it, that means that it's 0. And if I look at my graph, my y-intercept is at 0. If you fill in the plus 0, that's fine. If you leave it off, that's fine. They mean the same thing. Question number 19. Okay, we're going to look at one more together. So for number 20, again, we're going to start with vertex form. The vertex of my function here is -1, -4. So I want to put that into vertex form. So I know something needs to go here and something needs to go here. As I look at my vertex, the x coordinate is -1. That means I had to have x plus 1 squared. The y coordinate is -4, so that means I had to have -4 at the end. And then again, I'm going to look at the shape of my graph to see what my lead coefficient will be. From the vertex, get to my next nice point, right on the corners there. I'm going up 1 and out 1. So that means my lead coefficient would just be 1. If you want to write the 1, great. But remember, when it's 1, we're saying multiply by 1, which doesn't change our numbers. Now for intercept form, we're going to identify our x-intercepts. I've got an x-intercept here at -3, and then here at +1. So as I'm setting up intercept form, same lead coefficient. And then I'm going to have two factors. I have an x-intercept at -3. That means one of my factors had to be x plus 3. I have an x-intercept at 1. One of my factors had to be x minus 1. And then for standard form, I need to distribute one of these. So again, I'm going to distribute that intercept form. So x plus 3 times x minus 1. Again, be careful with your distribution. So x squared minus 1x plus 3x minus 3. And when I clean this up for standard form, I get x squared minus 1 plus 3 would be plus 2x minus 3. And again, double check your y-intercept from standard form with your graph. So if I look at my y-intercept here, I'm down at -3. Questions for me on number 20? Sophie? Oh, okay. Okay, you have 2 assignments to work on for the rest of our class time. You have a Delta Math assignment that's going to ask you, we've seen problems like this before. It's going to ask you, hey, if you want to know the x-intercepts for this graph, which function form do you need? So you'll tell it, I want factored or intercept form. And then it'll give you the function and you'll identify those x-intercepts. Or it'll say, hey, if you wanted to know the vertex for a function, which form would you want? You'll say, well, I want vertex form. And then it'll give you vertex form and you identify the vertex. It might also say, what if you wanted to know the minimum or maximum of graph? We know that's also going to be vertex form, right? Vertex form vertex is the minimum, or if it's flipped upside down, the maximum point on my graph. The vertex form would let me see what that point is. Okay. On your Khan Academy assignment, you're going to graph some parabolas for me. They're all given to you in vertex form. So you should be able to identify that vertex. Then to get your next point, if your lead coefficient is 1, we know what to expect, up 1 and out 1 to get my next points. Or if my lead coefficient is 2, up 2 and out 1. If my lead coefficient is negative, like it was on 18, we know we're going down and out. But if you get tripped up on that or you get stuck, remember that you can always find more points on a graph by making a table. So pick some values for x, plug them in, and see what you get for y. So for example, you may get a function where your lead coefficient is 3/4. So let's say that's the function that you get, and you're a little stuck on what to do with the 3/4, how to move, how many up or how many out. You just are having a hard time with that. Plot your vertex, and then pick another point on your graph. So if I plot my vertex at, this would be 1, 1, 2, 3. Pick 2 for x, or 3 for x, or maybe even 4 for x. But pick a point shortly after your vertex, plug it in for x in your function, and simplify to see what you get for y. Remember, anytime you're trying to graph a function, if you get stuck, you can always go back to making a table. Okay, that's always okay. That's a strategy we can always go back to. Questions for me? Your retake would be dependent on, the day will be dependent on what group you originally were. So Thursday would be a group 1 day. So if you were originally group 1, you'll take your retake on Thursday. If you were originally group 2, you'll take it on Friday. On the off day, I'll have an intro assignment for our next unit for you to work on. Okay.